Hello, grade 6. Welcome back to Nelson Math. Today we're looking at chapter 14, section 3, rotational symmetry. I'm going to tell you what rotational symmetry is. That's this definition right down here. Rotational symmetry is a shape that can fit on itself exactly more than once in one complete rotation. So a couple of things here. It must fit exactly on itself, not more or less. There can't be any overlap. And you count the number of times it does this in one complete rotation. So let's do that now. If you notice, if we start right here with this one, our corner of our center of rotation is right here, this black dot, and this is a square. We know that this is a square because all four sides are exactly the same length and all are right angles. This sticker of a star is starting off at the bottom right-hand corner. So we're going to count how many times this square fits exactly on itself in one complete rotation. So you can see our first starting of rotation here, we're moving clockwise. That's this way, clockwise, starting here, and we're moving, and here's our, it exactly lands right on top of the other square. So this is one. It's done it once, but we're now going to keep rotating it. We're going to rotate it again, and as we keep rotating it, here it's close to the top but not there, and this is two. So it's been rotated twice so far, but we haven't yet gone all the way around. It's not going to be all the way around until we go all the way once. So we've done it twice so far. If we kept doing this, we would notice that this star, if we rotated it again, would end up in the top right corner. That would be 3. And if we did it again, it would end up in the lower right corner. That would be 4. So this square, and any square for that matter, has an order of rotational symmetry of exactly 4. And the order of rotational symmetry is the number of times a shape will fit on itself exactly during one complete rotation. We're now going to do the exact same thing with this blue pentagon. I have marked one vertex of this pentagon with this arrow right here. This helps us keep track of how many times it lands on itself while we rotate it. So we're going to do that now. This is our starting position with the arrow pointing directly up. So we're going to rotate this one time, and now you can see that the pentagon has landed exactly on itself just once. But we have to bring this arrow all the way around. That would indicate the one full rotation. So let's do that again. And that's 2. Here, this is now landing exactly on itself. And that's 3. That's 4. And that's 5. So when we rotated this blue pentagon around exactly one time, it landed on itself 5 times. So the order of rotational symmetry is 5 for this pentagon. In your work today, you're going to be finding rotational symmetry and if shapes do in fact have rotational symmetry. This is going to be easier if you can find a way to trace and cut out the shapes. So as you rotate them, you can tell if they land exactly on top of each other. Thanks, everyone. Have a good day.